In our sky, is this one bulb or Betelgeuse? It's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous, very unstable, and about to explode. Get ready for a cosmic disaster of a never-before-seen scale. Betelgeuse, the red giant star on the edge of our galaxy, is sending scary signs through space. Astronomers have found something deeply troubling about this huge object using the James Webb Space Telescope. Well-known scientist Brian Cox has issued a very serious warning. The question that keeps coming up is, are we about to see a supernova explosion that will be so huge that it will change the night sky forever? In the vastness of the universe, stars are born, live, and die in amazing ways. Recently, one star has caught the attention and worry of both astronomers and regular people. This is Betelgeuse, a red supergiant star that stands out in the constellation Orion. It is very big and very old. Its unique reddish color and changing brightness have long been interesting, but recent events have made people even more interested in this cosmic giant. As we learn more about Betelgeuse, we are on the verge of a potentially extremely important event in its history. But what might these changes in Betelgeuse mean? Are we seeing the start of a cosmic show on an unimaginably huge scale? Betelgeuse is a stellar giant about 764 times bigger than our Sun. It is so huge that it is hard for humans to understand. Imagine a star so big that if it were to replace our Sun, its surface would reach beyond Mars's orbit and wrap around Mercury, Venus, Earth, and Mars. Not only does this huge size show how amazing Betelgeuse is physically, but it also shows what stage of its life cycle it is in. As a red supergiant, Betelgeuse is nearing the end of its life. It is expanding and cooling during this phase, which comes after turning hydrogen into helium in its core. What about Betelgeuse's age, though? This star is thought to be between 8 and 8.5 million years old, which is pretty new in human years, but very old in terms of stellar lives. It has been changing dramatically over millions of years, going from a hot blue star to the red giant we see today. It is now in its final stage as a red supergiant. Stars like Betelgeuse change over the course of their lives, caused by the constant pressures of nuclear fusion and gravity. Another thing that makes this stage of Betelgeuse stand out is its unique reddish color. Its red color comes from the fact that its surface is cooler than the surfaces of other stars like our Sun. The surface of the Sun is about 5,500 Kelvin hot, while the surface of Betelgeuse is about 3,500 Kelvin cold. Because it is cooler, Betelgeuse can give off light at wavelengths that make it look red. But this color isn't just a look. It tells us something about the star's physical state and the processes going on inside its huge gaseous volume. The fact that Betelgeuse's color has changed over time adds to its mystery. Writings from the Roman and Chinese eras say that Betelgeuse was yellow about 2,000 years ago. In the 9th century, Arabic experts were the first to say that it was red. This change in color over the course of human history is not just a small fact in the history of science, it also shows how the star evolved. Another interesting thing about Betelgeuse is that its brightness changes over time. It's a semi-regular variable star, which means that its brightness goes up and down on a regular basis. This dance of brightness has fascinated scientists and sky watchers for hundreds of years. Usually, Betelgeuse goes through a 400-day cycle and a longer cycle that lasts for 5 years. As early as 1836, Sir John Herschel wrote about these cycles, and Aboriginal folk histories may go back even further. But what really makes Betelgeuse mysterious is not just how bright it changes, but also how uneven it is. Unlike many stars that dim and brighten in a predictable way, Betelgeuse sometimes deviates from this pattern. This suggests that complicated and less well-understood processes are happening inside its huge form. Recently, astronomers and stargazers all over the world were shocked to see Betelgeuse's appearance change dramatically and unexpectedly. This is now known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, which is one of the brightest stars in the night sky and a prominent feature of the constellation Orion, started to dim in a mysterious way. The star was getting so dim that it started losing its light at a rate of 0.01 magnitudes per day on average. In February 2020, it was at its dimmest. Betelgeuse, which can usually be seen with the naked eye even in places with a lot of light pollution, got much fainter, and even casual viewers could see the difference. The time paradox, on the other hand, makes it hard to keep an eye on what Betelgeuse is doing because light takes so long to get to us. When we look at a star like Betelgeuse, we don't see it as it is now, but as it had been in the past. For Betelgeuse, the light we see today left the star almost 700 years ago because it is about 725 light-years away, because we are looking into the past of the star. This time lag makes it hard to predict and keep an eye on quick changes in its behavior. The Betelgeuse lowering event was a reminder of how hard it is to observe the sky in real time and how little we know about the big, strange worlds of space and time that they create. Andrea Dupre, Deputy Director of the Center for Astrophysics at Harvard and Smithsonian, and her team closely watched the events of Betelgeuse's celestial drama as part of a 3-year study to track changes in Betelgeuse's outer atmosphere. They used Hubble to look at the huge star. These observations gave a new look into how a variable star like Betelgeuse works. Variable stars regularly get bigger and smaller, which causes changes in how bright they are. Researchers were able to look into the layers above the star's surface, which were heated in part by the star's swirling convection cells, thanks to Hubble's sensitivity to ultraviolet light. More study of the Hubble spectra, which were taken at different times in 2019 and 2020, helped figure out how fast things were moving in the upper atmosphere of Betelgeuse. The spectra were mostly made up of magnesium-2 lines, which show what the star's atmosphere is like. The studies showed that things were moving from the star's surface into its atmosphere at about 200,000 hours mph. This hot, dense stuff finally reached millions of miles away from Betelgeuse. It was the start of the dust cloud that made the star less bright during the 3 months of the outburst. Dupree and her team thought that about twice as much material as usual from Betelgeuse's southern hemisphere was lost. While all stars lose mass over time, Betelgeuse's loss was especially noticeable because it happened at a much faster rate than the Sun's. Astronomers talked about whether this event could be a sign of a supernova explosion because of how big this mass release was and how dim it became afterward. Being only about 725 light-years away from Earth, Betelgeuse adds to the mystery because any explosion like this would be visible from Earth and give people a rare chance to see a supernova up close. But the question still stands. What does this lowering mean for Betelgeuse's future? Is it a sign that a supernova is about to happen, or is it just a one-time event in the star's long and complicated life? Several ideas were put forward to explain this quick change. One popular theory said that there was a stage in the process of a supernova explosion. This idea caught on because most people think that Betelgeuse is almost done with its life. Another common idea is that dust, maybe from the star itself, is blocking our view. It is known that Betelgeuse and other red supergiants lose stuff. It was thought that this stuff could build up into a dust cloud thick enough to block our view of the star's light. A third idea looked at how changes in the star's photosphere, the visible layer on the outside, might have an effect on how bright it seems. This puzzle was solved by using a lot of different observational methods and in-depth analysis. Spectroscopic studies showed that Betelgeuse's effective temperature dropped. This suggests that the star may be dimming because of a big dark spot on its surface. The fact that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming supported this idea. This showed that there were big changes on the star's surface. In the end, the Hubble Space Telescope, humankind's watchdog in space, helped us figure out what was going on with this strange event. Hubble's views showed that the dimming of Betelgeuse was probably due to a large amount of hot matter being thrown into space. This stuff made a cloud of dust that covered up some of the star's surface, which meant that less light from Betelgeuse reached us. It was thought that the dust cloud was made of very hot plasma that erupted from a big convection cell on the star's surface and moved through its hot atmosphere to the cooler layers on the outside. It formed dust grains as it cooled, making a cloud that blocked light from about a quarter of the star's surface. Hubble's ultraviolet light spectroscopic studies, which began in January 2019, were very helpful in putting together the events that led to Betelgeuse getting darker in the months before the dimming. These studies showed signs of dense, hot matter moving through the star's atmosphere. Several ground-based telescopes also saw the star getting less bright in December 2019, especially in its southern half. The stuff that was there at first was brighter than the star itself, but as it moved outward and cooled, it turned into a dark cloud. The idea was that this outflowing matter and the dark cloud it made were what made the star suddenly dim. This explosion is truly huge, and it has put Betelgeuse in the center of astronomy. The star threw out about 400 billion times the mass that is usually thrown out in a normal coronal mass ejection. This material being thrown out, which is thought to weigh several times as much as the moon, was a big deal for both Betelgeuse and our knowledge of how stars work. But what does such a huge explosion of matter mean for ideas about Betelgeuse and supernovas in general? It has huge effects on ideas about supernovas. Red supergiants like Betelgeuse are thought to lose mass at a fairly steady rate before they explode at the end of their lives. The size of this ejection, on the other hand, calls this idea into question. It points to a more turbulent and possibly uncertain end of life for these stars. Could Betelgeuse be getting ready for its big finish, a supernova explosion in a few thousand years? New studies make guesses about when this kind of thing might happen and say it might happen sooner than thought, maybe in just a few tens of years. Another important piece of the Betelgeuse puzzle is the idea of bow shock. This huge star hurtles through space at about $67,000 mph, compared to the material between the stars around it. It makes a bow shock, which is like the wave that a moving ship's bow makes. This effect happens when the star's outer layers interact with the gases and dust in the space between the stars. It's a beautiful example of how lively the star is and how it interacts with its surroundings. This bow shock not only tells us about Betelgeuse's current state, but it also helps us learn more about how stars change over time and how mass is lost. But what about the star's past actions? It has been seen that after the release, Betelgeuse's surface cooled and became less dense. This means that the star is still unstable years later. Hydrodynamic models show a link between the star's convective activities, the mass ejection, and the change in pulsation mode that follows. This constant uncertainty makes us wonder what's going on inside these changes and how they might end in the future. Also, Betelgeuse's mass loss rate is much higher than that of many other stars, which suggests that its internal forces are working together in a complicated way. The forced pulsation that is part of the reason for this mass loss is limited by the fact that energy is always being lost through shock heating and mass ejection. These observations show that Betelgeuse's life cycle is very dynamic and not always predictable. This makes scientists think again about their models of how stars evolve. With all of these big changes, though, one might wonder if Betelgeuse is about to go supernova. The question is very important to people who study astronomy. The exact date of such an event is still unknown, but the recent unusual mass ejection has changed the subject and made people think that the end is closer than they thought. Theories are now trying to figure out what this huge loss of matter means for the star's health and future. While astronomers are focused on Betelgeuse, the supernova SN 2023 EXF is also getting a lot of attention and can be used to make interesting comparisons. This amazing explosion happened in Messier 101, which is also known as the Pinwheel Galaxy and is only 21 million light-years away. SN 2023 XF, which was found in May 2023, isn't just another supernova, it's the closest one seen in recent years, giving scientists a great look at the end of a star. It was like a cosmic coup when SN 2023 EXF was found. Koichi Itagaki, an amateur scientist who is famous for finding supernovas, first saw this quickly brightening spot on the edge of Messier 101 with a small 0.35-meter telescope. As soon as he told everyone about his discovery, the astronomy community got to work. From the surface of Earth to the Hubble Space Telescope in space, telescopes all over the world turned to watch this new supernova explode. The race to keep an eye on SN 2023 XF's light curve gave scientists important information about the explosion and the area around the dying star. SN 2023 XF's behavior was carefully recorded during the rough month after it was found. In just 5 days, the supernova went from being pretty dim to being very bright. It then started a more steady decline, dimming by 0.03 magnitudes every day. A study of the spectrum showed many bright emission lines, which show how strongly the growing supernova shockwave and the gas around the star were interacting. It wasn't just a star dying, it was a huge star falling under its own weight as its nuclear fuel ran out. The outer layers blasted off the dense core in a spectacular core collapse supernova. But what's really interesting about SN 2023 XF is the dense shell of gas that surrounded it. This made it much harder for the shockwave to escape from the middle of the star. There are 2 possible explanations for this dense material around the star. Either a strong, steady wind was blowing material off of the star before it exploded, or the star had random explosions that threw material into space. In any case, the star is thought to have lost up to a solar mass of matter in the last 1 to 2 years of its life, which shows that its last moments were anything but peaceful. The main goal of research is to find the parent star of SN 2023 XF. Researchers have used a variety of methods and statistics to come up with a likely candidate: a red supergiant. Astronomers can improve their models of how stars form and how supernovas work by studying the specifics of SN 2023 XF's explosion, such as the features of its parent star and the processes that led to its final blast. These new ideas directly help us understand what's going on with Betelgeuse right now and how it might end up going supernova. They give us a better idea of what signs to look for and how to understand the huge red giant's complicated behaviors. But when will Betelgeuse become a supernova? Tohoku University researchers think that Betelgeuse may be in the carbon-burning stage of its life right now. This is the stage that stars usually go through before they die. Haoki Sao, who is in charge of this work, thinks that the star's core might fall apart a few tens of years after the carbon runs out. On the other hand, scientists at Hungary's Konkoly Observatory think Betelgeuse is in an earlier stage of burning helium. There are different opinions, but most agree that Betelgeuse will likely be the next supernova in the Milky Way. However, this event might not happen for another 100,000 years. In the past, looking at supernovas has given us a lot of useful information about how stars die. In 185 CE, the first known record of a supernova was made. It was seen as a bright star that disappeared from the sky after 8 months. Since then, many important supernovas have been discovered. These include SN 1604, which was the biggest star ever seen in the night sky and could be seen from many places around the world, and SN 1054, which caused the Crab Nebula to form and could be seen during the day for 23 days. The most recent supernova seen in the Milky Way was SN 1604, which Johannes Kepler studied in great detail. Recently, supernova 1987A in the Large Magellanic Cloud was seen just hours after its light reached Earth. It was the first supernova to be seen through neutrino radiation and in all electromagnetic spectrum bands. These observations have been very helpful in making accurate models of how supernovas behave and figuring out what part they play in the formation of stars. What if all of a sudden the night sky erupted in a brilliant show of cosmic fireworks and the bright explosion of a star caught our attention? Imagine for a moment that the once familiar constellation of Orion had a new bright star added to it. Betelgeuse, one of its brightest stars, had become a supernova. What kind of effects might this amazing event have on Earth? Betelgeuse is about to go through a core collapse supernova, which is a type of explosion that happens when huge stars run out of nuclear fuel and can't support their own gravitational collapse. Core collapse supernovas are some of the most powerful and destructive events in the universe. It will take only seconds for Betelgeuse to go supernova, but it will release as much energy as our sun does in its billions of years of life. Most of the energy that a supernova gives off is electromagnetic radiation, which includes X-rays, gamma rays, and light that we can see. A Betelgeuse supernova, on the other hand, would cause a spectacular light show in the night sky that we could see right away. For a short time, the blast would be brighter than the moon, and it could be seen during the day. Imagine looking up at the sky during the day and seeing a second, much brighter sun appear for a few weeks, or even months. Astronomers and people who just like to look at the stars would both be amazed by the event. But as interesting as it would be to see a Betelgeuse supernova, its real importance lies in the science questions it raises. Supernovas, especially those that happen when very large stars like Betelgeuse explode, are like laboratories in space that teach us a lot about how the world works at its most basic level. One of the first perks of watching a Betelgeuse supernova would be the chance to see up close the last stages of a star's life. When very big stars like Betelgeuse blow up, they send heavy elements like iron into space that were formed inside the stars. It is this process that adds the building blocks of planets, stars, and life itself to the world. Scientists can learn more about how stars change over time, how elements fuse together, and how they help make new celestial bodies by looking at the spectroscopic signatures and the spread of these elements after a supernova. This information is very important for figuring out the universe's past and makeup. The visible light from a Betelgeuse supernova would be very bright, but the neutrinos that would be released are just as interesting. Neutrinos are subatomic particles that are extremely hard to find because they don't interact with matter very often. In the intense climate of a supernova, on the other hand, huge numbers of them are made. These hard-to-find neutrinos give us a unique look into the heart of a dying star. They can tell us about how the core collapses, which helps us understand the basic forces and particles that are at work during a supernova explosion. Finding and studying these neutrinos would be a huge step forward in science, and it might lead to new information about the universe's harshest conditions. The discovery of a Betelgeuse supernova could also change how we think about the spread of the universe and the mysterious force called dark energy. In the late 1990s, scientists looked at supernovas far away and found that the expansion of the universe is speeding up, not slowing down as they had thought. Because it is so close to Earth, the Betelgeuse supernova would be a good place to collect data on the rate of expansion of the universe and the part that dark energy plays in driving it. It might help us better understand these basic ideas about the universe, and it might even lead to new mysteries about the universe's structure and fate. What could happen on Earth if there was a Betelgeuse explosion, though? Is the world in danger? Because we are so far away from each other, this is not likely to happen. 1 light year is about 5.88 trillion miles, which helps you understand how big our universe is. At 725 light years away, Betelgeuse is more than 4,267 trillion miles away from Earth. There is a certain amount of cosmic shielding because of this huge distance, and it is very unlikely that the explosion itself will hurt Earth directly.